the next thing is about our object format, single object, and the way we do objects is changing. This is an opt-in. You don't have to do it if you don't want to, but this is an opt-in which might eventually become the standard and will be an opt-out. But for the moment, it's so. Let's do this basic. So you're all familiar with that. We've catalogued 4 programs. Catalog BP. There we go. This, and if we look in the library, this is typically what we do. All those 4 objects we merge into one single object called that. So those 4 routines, sub1, sub2, sub1 in lowercase, and the main program are all in there. And that's how we've done it for decades. We've got a new model now. Let's get rid of that. We go, and all you do is go equals 1. It's an environment variable, and we'll compile and catalog. And now if we look in the lib directory, each one of those modules has got its own shared object. So instead of building one big one, we now have one per source code. So you might say, whoopee, what difference does that make? Well, the difference is you can just move these objects here, are much easier to manipulate. You can move them between accounts, you can FTP them, you know, because they're not part of one bigger object, they're much easier to handle. If you want to, if you make a change to an object and you want to distribute that to different systems, you now only have to distribute one single shared object, which you know is the one you've modified. We've had a lot of problems with customers getting these things, getting JBASE into a bit of a mess with this, and hopefully this should stop all of that. What else do? We tag meta information in it. So if I do this, JELF, display. So we can do this, we can see all the shared objects, and we can see what the label is. We know what subroutines in there, what emulation, and if there's embedded source code, and we'll come on to that in a second. Here is a window. This is one from our QA suite, which has got a slightly different, it's got lots more stuff to look at. So if we go JELF list, it's got a lot of stuff there. And here we can see all the emulations. Because it's our QA suite, we emulate stuff in, you know, in different emulations. So we keep a lot of meta information about who compiled it, what options they used. We can give warnings when you try and catalog it. Somebody might have used a different emulation when they recatalog it, and we will give a warning now. Stuff like that. Here's something else we do. I won't. We'll go into D3 emulation. And now it's giving us an error because I've got 2 subroutines, one called sub1 in uppercase and one called sub1 in lowercase. And in D3, that is a problem. You know, in non-D3, it's quite valid to have 2 different subroutines, but with different cases. But in D3, you can set it so, set a debug option, and it'll tell you that. If we can also set the debug option to 3, and then it tells us everything about everything you load in terms of your object. Here's something else, because I've only got a few minutes, here's something else you can do. Onset emulate, export J key equals. So what we're doing there, we're saying the objects, as well as having all that metadata, they're going to have the source code in, but we're going to encrypt it with that key. So we're going to do that, basic, and rebuild everything, catalog BP. Now if I go prog, I'm just going to debug it. And it's asking me for the key so that it can find the source code for it. And if I put in an invalid key, it just keeps prompting. So COVID-19, there you go. And now I can debug it. the beauty of that is that VARs can distribute their object code with their source code built into it, and the source code's encrypted. So if there is a problem on site, you can dial into their system and debug it, and you'll have the source code that was used to build it actually on site, but the customer, the end user, can't see it because it's encrypted with a security key. So I think that's a useful feature. Here's a nice little feature, JELF verify. We'll go back to the QA suite. That found 1,802 objects, and there's no problems. What it does, because the metadata's got the name of the file and the item ID that was used to compile it, it goes through all the objects and makes sure that you've got source code that matches it. And I'll run that on here. And if you go, here's another thing you can do, rebuild APPLY. So what I'm going to do now that I've verified it, I'm going to ask it to rebuild everything. And it'll go through all the objects, find all the source code. It knows all the options and the emulations and everything that was used to compile it originally, and it'll just rebuild it. There you go. And it's rebuilding all the objects from the source code, and it just does that automatically. And it can do this because now in the object code, it's got all this metadata. That's a useful feature. Let's do it on here. I'll show you. JELF verify, and it should work. COVID-19. There you go. Now let's go BP, what should I do? Sub 1. So I'm going to change the source and run the verify. And now it's telling me the hashes don't work. It's knowing that there is one of the source codes that doesn't match, the source code that was used when you originally compiled it. So something's out of date or something's gone wrong, and that's a really useful feature. That's it in 10 minutes.